All right. So what I'm going to do is to guide you through the three parts first, and then you will try the question by pausing the video, and then you can check the answer after you've tried. So for the first part in the question says P divides AC internally into the ratio of 4 to 7. So this part is 4 parts and this is 7 parts. So this is pretty standard. You can apply the section formula to find the coordinates of P. Part B1, prove that PB equals PD. What does that mean? It means the length of PB, okay? It's asking you to prove that the length of PB is equal to the length of PD. What in this chapter or in the previous chapters have you learned that would allow you to calculate the length? So think about that. And then B2 is about, okay, so since PB is equal to PD, does it mean that P is the midpoint of BD? Does this imply this? Think about it. You definitely have learned midpoint, how to find midpoint of 2 points, right? Given their coordinates. And I will explain a little bit more about the situation after you finish the question. You may pause the video now and try. All right, so you should have tried the question already, and now you can check the answers. So using the section formula, you should be able to find the x-coordinate and the y-coordinate of P. So the coordinates of P should be 0, 3. And to find the length of PB and PD, you can use distance formula. You will find them both to be square root 13. Now, in cases where your root is not a perfect, like integers, not an integer or terminating decimal, just leave it as a cert form, okay? Because here it doesn't require you to correct this value to, say, 3 significant figures. Just leave it as exact. As long as you can show these two values are equal, then you're good. And then moving on to B2. So we know that PB is equal to PD. Does it mean that it is the midpoint? Well, we know how to use the midpoint formula. And then we notice that the midpoint of BD is not P. Why would that be the case? Now, let me make a small sketch here. So what happens here is the P and the D, B and D, okay? They're of equal lengths, okay? But imagine that this is PBD is an isosceles triangle. Then if this is actually an isosceles triangle, of course, we know that P will not be the midpoint of BD. And for isosceles triangle, of course, these two legs should be the same, okay? So there are actually many situations that would make these two legs being equal, but P not being the midpoint of these 2 points that are equal distance from P. Okay, so just want to remind you that this statement in B1 does not imply that P is the midpoint of BD. Now let's say if let me scroll up a little bit. So let's say C is the midpoint of AB. Obviously, AC is equal to CB. Okay, so if C is the midpoint of AB, then AC has to be equal to CB. But only knowing that the two legs are the same, CE is equal to CF, does not mean that C is the midpoint of EF. Because imagine there are just so many isosceles triangles that you can draw, but C is actually the third vertex instead of the midpoint of EF. Otherwise, there will be no isosceles triangles that can be formed. So, this situation in the question is basically saying that PBD forms an isosceles triangle. PBD forms an isosceles triangle, and P is the third vertex, while B and D are the base angles.